Assalamu alaikum students. We continue exercise 3.2 with question number 4, in which we are required to find out the replacement of the unknown in each of the following statement to make the statement true. So for this purpose, if we recall the definition of logarithm of a real number. As we recall the definition of logarithm of a real number, now we can easily do this sum. So let's do it. Writing in exponential form. As we are now familiar, the base will remain base. These values, two values will exchange their position. L will become exponent and 81 will become equivalent value. As we know that 81 is a composite number and we are very much familiar about that, composite number can only be solved by prime factorization. So the prime factors of 81 are 3 into 3 into 3 into 3. 3 3s are 9, 3s are 27, 3s are 81. In a product, if bases are same and the powers are added, so we apply law of sum of powers over here. So 3 raised to power 4 we have, and left hand side we carry. In an exponential equation, if bases are same, then powers are equal. So therefore L will be equal to 4, and hence we find the replacement of L, that is 4. If we put 4 over here, and that statement will become true. Students, definitely a question arises in your mind, that is, what is meant by exponential equation? So I will briefly tell you that exponential equation is an equation in which variable occurs in exponent. Exponential equation. It is an equation in which variable occurs in exponent. And the property which we use over here, that is, if b raised to power x is equal to b raised to power y, then it implies that x is equal to y. As we observe that the bases are same, so therefore according to the exponential equation the powers are equal. Let's do the next part of this question. Again, we are dealing with logarithmic form and we have to write in exponential form according to the definition of logarithm of a real number. Base will remain base and these values will exchange their position. 0.5 will become power and 6 will become equivalent value. As 0.5 is a decimal value, so we remove decimal and writing as 5 over 10. 5 ones are 5 and 5 twos are 10. So we have a raised to power 1 over 2 is equal to 6. So taking square of both sides. Why we take the square? As we are required to find the unknown value of a, and so therefore we have to remove that power 1 over 2. So definitely when we multiply by 2, so power will become 1. So hence we take square of this side And if we take the square of the left hand side, we have to take the square of the other side. So therefore, we take the square of the both sides. A raised to power 1 by 2 whole power 2 is equal to 6 raised to power 2. That power 2 is cancelled by this 2 as they are reciprocal of each other, inverse of each other, and we have left A on the left hand side, and 6 raised to power 2 means 6 multiplied 2 times. 6 multiplied 6 is equal to 36, and hence we got the replacement of A equal to 36, and by putting this value over here in the space, the statement will become true. Now we move to the part 3 in which another logarithmic form. So writing in exponential form according to the definition of logarithm of real number. We write base as same, that equal value will become power, and we have n on the right hand side. 5 raised to power 2 means 5 multiply 5, and that is equal to 25, and hence we got the replacement of n is equal to 25. Now move to the part 4, and that is a little bit different. We are dealing with exponential form. So it means we have to write in logarithmic form. Writing in logarithmic form according to the definition of logarithm of real number. Base will remain base with log. So log base 10 we write, and 40 will be written with log. So it becomes log 40 to the base 10 is equal to P. Using log table or calculator, we find the value of log 40. As we know that log to the base 10 is a common logarithm, therefore its value of log 40 is 1.6021 by using calculator. So hence the replacement of P is 1.6021. That's it for the question number 4.